All right, stats section, stats. This is section 4.4. It's on conditional probabilities and independence. So a couple of complications for the probability stuff we've been studying. Okay, example, list the sample space for flipping a coin twice. The sample space, that's a list of everything that could happen. So we usually use, put a bracket there. And here are the ways flipping a coin could go. Heads and heads, heads and tails, tails first and heads second, and then tails and tails. That's the way that could go. By the way, I know there's four things because the first time I flip a coin, there's two options, heads or tails. The second time I flip the coin, there's two options, heads or tails. The multiplication counting principle, which I think you learn in like middle school, says that you multiply those and you come up with four total possibilities, and I just listed all four of them. Okay, find the probability that when you flip the coin, heads comes up twice. Well, if this is all the ways it could happen, and they're equally likely to happen, then the probability of heads and heads is just equal to one way that can happen out of four ways the sample space can happen. Okay? Now list the sample space if you know the first flip comes up heads. Well, these are out. So as soon as I know something, we're talking about conditional probabilities here. That's a condition. If the first one's heads, all we got is heads, heads, and heads, tails. It's no longer out of four possibilities. It's now out of two possibilities. So now find the probability of having heads come up twice. Well, now that's probability of heads and heads is out of a smaller sample space. It's only out of two possibilities. So there's that one way this can happen, but now it's only out of two possibilities. Now that should make sense to you because the probability of two heads, well, if you know the first one came up heads, well then really it's just the probability of getting heads when you flip a coin. Isn't that just 1/2? Right? So that's an easy example to kind of prove a point. When I know something happened, it makes the sample space smaller. It makes the denominator smaller every time. The second probability that we did here, not the first one, the 1/4, this 1/2, is referred to as a conditional probability. We definitely need to know how to find some conditional probabilities. There will be several questions about that this chapter. Because you were, I'm going to put in quotes, you were given some information that helps make the sample space smaller. You were told, hey, heads came up first. Let's talk about what happened second. We write is like this. That doesn't make sense. That should say we write it like this. I'm a loser. It will go like this. What's the probability of getting heads to come up when you flip the coin? Now watch this. A little vertical line segment here, and then heads. What that means is, given that heads came up, what's the probability? So I want you to think of this vertical line as the word given, okay? What's the probability that heads comes up when I flip a coin, given that heads already came up? Which means the probability of heads given the fact that heads came up, like I just said. Okay? Definition. The probability that one event happens given that another one happened or is known to have happened, that's called a conditional probability. So here's your definition for it. The probability that one event happens given the fact that another one is known to have happened is called a conditional probability. The conditional probability that A happens given that B happens goes like this. The probability of A given B. That's the notation for it. So like think about it in class. If I was going to give out extra credit to somebody, what's the probability I pick you given that I'm going to pick a girl? Well, if you're a guy, it's over. You're out. If you're a girl, now you're not one out of the whole class. Now you're one out of, somewhere around half of the class. Okay, let's go to the second page.